Hello there, my name is Christopher Worse and welcome to the second video of the Homework 2 from Material Energy Balance. This is going over the second question of the homework. Starting from the generic cubic equation of state, derive a cubic polynomial expression for the compressibility factor. So, as you can see behind me, and in the first video, we found the compressibility of a critical, in the critical state. This is somewhat using that, somewhat not, but it's using the compressibility. So we are familiar with Z, the compressibility factor. We're using that to find a cubic polynomial for it. So I'm going to move over here. This is the class 1 note, but nothing on the screen is, there's nothing really to help me on the screen here, so we're good there. So I'm going to erase the screen behind me, the whiteboard behind me, but on the screen here, this one, that is the all-important equation for this problem. So let me get to erasing this. You're using some important things to remember. This will work. That should work. So let's write it on the board. Just for preparations, pressure equals R times temperature over volume minus B minus A over, now this is new, this is different, but epsilon and omega here denote B's that are important, or denote coefficients that are important for calculations. So V plus epsilon B, V plus volume plus omega B. That's a vitamin. Take your vitamins. Now, the only things that we need after this are not this, not this. Well, we will need this. The fact that the pressure and volume over the derivatives of them are 0. We will need that. But we will need these two values here, beta and Q. So let's call it, I'm not good with Greek letters, so let's call it big B. Capital B equals lowercase b times the pressure over R times temperature. And then Q, another important one, equals A over B, R, the temperature. Okay. Now, from there, we can start to derive a cubic polynomial expression for the compressibility factor. So, now that we have this, well, what are we looking for? We're looking for the cubic polynomial of the compressibility. So we need to get the compressibility from here. Well, compressibility is the pressure times the volume over R times the temperature. So, first thing we're going to do is divide both of all three of these by R times the temperature. This is going to cancel. We're going to get, goes to pressure over R times the temperature equals 1 over V minus B minus A over R times the temperature V plus epsilon B, V plus omega B. Now what else we need? Well, we need V. So we're going to multiply all of this by V. So PV over RT equals V over V minus B minus pressure times volume over R times temperature equals volume divided by volume minus B minus A times volume over volume times R times the temperature, volume plus epsilon B, volume plus omega B. Now, obviously, these cancel. Let me get these. Look at that. So, these So hey look, we have Z. Well, now what? Well, we want to start getting Q and B. So to do that, we're going to, and remember, look, we have V here, we have V here, we have V here, we have V here. We can start canceling things out. Equals, well, if we V volume divided by volume over 1 minus B over volume, V's cancel out, minus A times volume over, so we're going to factor volume out from these two individually, volume squared, times R times temperature 1 plus epsilon B over volume 1 plus omega B over volume. So these will cancel out as well. So now we have Z equals 1 over 1 minus B divided by volume minus A over V times R times the temperature 1 plus epsilon B over volume 1 plus omega, oops, 1 plus omega B over volume. Okay, well now what? Well, if we look at this, this is very close. Something else is very close here. So, we're going to narrow down here. Oops. V equals R over T divided by pressure. Oops. No, we want to use it here. Wrong equation, wrong error. I want to use it from here. So, V equals Z R T over P equals a volume. So, we found Z equals, we're going to start adding them in. 1 over 1 minus B divided by, so B times pressure divided by Z R T, the temperature, minus A, again, divided by, so A times pressure divided by Z R squared, temperature squared, 1 plus, epsilon, it's the same here, B times pressure over Z R times temperature, and then the same thing here, 1 plus omega times the pressure, oops, omega B times the pressure, Z divided by Z times R times the temperature. Some of these look familiar. A lot of these look like a beta or big B in our case. Well, it's beta. So I'm going to circle all the betas. Oops. That's not a beta. Circle the wrong thing. B times pressure over R times temperature times Z. There. This is beta. Well, this is beta. This is beta. Now let me double check that I got that right. Beta over beta times P over RT, beta times P over RT. Yep, all right. Beta times pressure divided by R times temperature. So Z equals 1 over 1 minus beta over Z minus A times pressure divided by ZR squared T squared 1 plus epsilon beta over Z 1 plus omega beta over Z. Now, we don't like having A here, so we're going to get rid of it. So we're going to use Q. We're also going to do our best to get rid of this here. So we need a B. So, well, what is beta? Beta is B times pressure times RT. Well, we have pressure R and T here. So if we did that, beta would go to beta over B equals pressure over R times temperature. So we can also circle these, move this along to z equals 1 over 1 minus beta over z, beta over compressibility, minus A times the pressure over compressibility, whoops, A times beta over compressibility RTB, 1 plus epsilon beta over compressibility, 1 plus omega beta over compressibility. Well, now we have this. Now we have Q, A over B times RT. There. So, one more. Z equals 1 over 1 minus beta over Z minus Q beta over Z 1 plus epsilon B over Z 1 plus omega beta over Z. Now, it looks like here, this is at a terrible angle. Let me rewrite this in a better way. Compressibility equals 1 over 1 minus beta over Z minus Q times beta over compressibility, 1 plus epsilon beta over Z, 1 plus omega beta over Z. It's at a better angle for you. And you can see that. There are a lot of Z's in here. So there's a Z over here that I don't really want. This can only cover one of them, so I'm going to divide this entire thing, or multiply it by 1 over Z, and I'm going to bring it up over here. There. You can't see it very well, but that's an arrow. It's just denoting that we're going over here now. So Z over Z equals 1 over compressibility times 1 equals compressibility minus beta minus Q times beta over, we're going to factor this Z, this compressibility into here, and this one into this one, equals compressibility plus epsilon beta times compressibility plus omega beta. Well, this looks interesting. You know, I think I could form a cubic equation with state out of this. So we are. So we're going to first multiply, cross multiply here to get 1 equals, this is not a very good marker, I apologize. 1 equals compressibility plus epsilon beta times compressibility plus omega beta minus Q times beta times Z minus beta all over Z minus beta times Z plus epsilon beta times Z plus omega beta. And we're going to multiply this over here, so in total, Z minus beta times Z plus epsilon beta times Z plus omega beta equals, and I'll write it underneath, Z plus epsilon beta times Z plus omega beta minus Q times beta times Z minus beta. We're going to, now we want this to all equal 0 because that's how we get cubic equations, and we can do that. I'm also going to start factoring a little bit. So let's begin with the first one. Let's start with these two. We're going to factor those two, these two. So compressibility minus beta times Z squared plus omega Z compressibility times beta plus epsilon times compressibility times beta plus omega plus epsilon times beta squared. Now, subtract this minus Let me get a different marker. I'll be right back, I apologize. All right, let's check. That's better. Hopefully you can see that. Minus, yeah, much better. Minus this entire thing, because we already factored it. So minus z squared plus omega times z times beta plus epsilon times compressibility factor times beta plus omega times epsilon times beta squared plus z compressibility times q times beta minus q times beta squared. Now this all equals 0. So let's finish factoring everything out, cancel, and we have a cubic equation. So let's start with this. Z cubed plus, and I'm going to factor these two, omega plus epsilon, z squared beta plus omega times epsilon times z beta squared, and over here, minus z squared b minus omega plus epsilon times compressibility times b squared minus omega times epsilon times b cubed. There, that's this entire thing, this all factored out. Now we can subtract these minus z squared plus omega times z times beta plus, and again I'm going to factor these, omega plus epsilon times compressibility times beta plus omega times epsilon beta squared plus z times q times beta minus q times beta squared. So I'll now separate out z cubed, z squared, z, and then just 1. So I'm going to now sort this into things that are in the individual regions. So all of the factors, all the numbers with z, the compressibility factor cubed will be this squared to the power of 1 to the power of 0. So the only thing we have z cubed is this, so it's just going to be 1. That's a bad 1. 1. That's better. Then we have z squared, we have this, we have this, we have this, and that's it. So omega plus epsilon b minus b minus 1. And remember, this is going to be multiplied out, so you have that. So 1 times z cubed equals z cubed. Omega plus epsilon times b times z squared equals this. Negative beta times z squared equals this number. Negative 1 times z squared equals this. So now we have numbers with just z, and I'll square them. Square just z here, just z here, and just z here. So we have omega times epsilon times beta squared, negative omega plus epsilon times beta squared, positive omega plus epsilon times beta, not squared, and then positive q times beta. And then everything else that's not done, this, so is going into 1. So negative omega times epsilon b cubed plus omega times epsilon times b beta squared minus q times beta squared. And the only reason that I swapped that out is because that'll be useful for coding later. It's pretty important. It makes it much easier than this mess. Even if this wasn't shaped up as I did to factor it out, this is still not a great thing to code out. It's time consuming. It's not great. But here I will make sure to equals 0. Star this. This right here is our cubic equation of state that we can use with some Wikipedia values or some values that have already been formed to plot isotherms, to find temperatures, to find volumes, and all of that. And with that, we finished question 2. So thank you very much for watching. I hope you have a wonderful day. Hi there, Future Chris here, noticing that I just made a mistake in the calculations and specifically in the work and order of operations here. I missed something, so I've written out the cubic equation. I will put equals 0. So to remind you, you've seen it, you saw it a little bit ago. You probably don't need the reminder, but z cubed plus, speaking of, this is not omega. I figured that out after creating the video, but this is actually sigma. So sigma plus epsilon times z squared times beta plus sigma times epsilon z times beta squared minus z squared times beta minus sigma plus epsilon times z times beta squared minus sigma times epsilon beta cubed minus z squared plus sigma plus epsilon times z times beta plus omega times epsilon times beta squared plus z times q times beta minus q times beta squared. Now, the issue here isn't necessarily that any one of these individual numbers or values is wrong. It's that I forgot parentheses. These are important parentheses because it means that the minus is going through everything here. So let's write out the z cubed, z squared, z1. Okay, so we have z cubed here. So we have sigma plus epsilon b times beta plus sigma times epsilon times beta squared minus z squared times, so minus beta, negative beta, then negative sigma plus epsilon times beta squared minus sigma times epsilon times beta cubed. All right, that is this. Now that we have this, minus 1, so 1 times z squared is z squared, minus sigma plus epsilon times beta, minus sigma times epsilon times beta squared, and then plus z times q beta minus q beta squared. There. Oh dear. This cap seems to be stuck. Anyways, sorry about that. Broke the marker. This is the correct, this is now here, the correct equation, albeit not fully factored or fully as clean as it could be, but this has everything in it there's no cancellations or anything like that. So thank you very much for watching. Hope you have a wonderful day.